Hey guys, I went ahead and did this presentation for you today to kind of help you out with your capital needs analysis on using Microsoft Excel functions for retirement. So if you'll take about, this presentation's only about 15, 16 minutes, but I really want to make sure that you understand how to use the Microsoft Excel functions, present value, future value, payment, the rates, and using Microsoft Excel and calculating a capital needs analysis or your retirement needs analysis. It's not that hard, but if you do need any help or if there's anything I can do for you, I'll be more than happy to walk through on a Google Hangout with you on how to do yours on a practice problem, or we can talk via phone. So I hope that this helps. Hey guys, hope you're doing well today. Today my goal is to kind of help you guys out a little bit with showing you how to calculate the capital needs retirement analysis in Microsoft Excel. So the first thing I want to do is go through kind of the numbers that we're working with here. So we have a client who needs $100,000 in retirement per year. They're going to get Social Security, not a pension, but it works as a pension, but they're going to get Social Security benefits every year during retirement, $20,000. Current age is 30, their retirement age is 65, and the end of their plan, we don't ever want to say you die at this year. That would be, we gotta be a little bit nicer. Say we call it the end of the plan. So first step, let me show you how I set this up. Now I set this up, and I just type in these numbers right here. We'll talk about what they mean in a second. Okay, so what is the first thing we're solving in step one? Okay, well, present value. Do we know what the present value is? No, that's what we're looking for. We're looking for how much money at the age of 65 does this person need to live in retirement. What's the future value? Well, in this situation that we're doing, we know the future value is going to be zero. So I'll just put $0 in there. What's the payment going to be? Well, this is the payment that they're going to be. And remember, this problem is done at age what? This is 65 through 90 on our timeline. Okay? So this is 65 through 90. Payment is going to be our $100,000 per year. But look, they're going to get $20,000 per Social Security. So they need technically, and this is really, you don't even need to do this, but I'll do it. They need $80,000 per year. Now, we'll skip the rate, and we'll come back to that in a second. How many years do they need this? Well, they need it equals when the end of their plan minus their retirement year. So they need it for 25 years. Now, let me ask you a question. Are they going to need the money, the $80,000 per year, at the beginning or at the end of each year? Well, I can tell you this. The landlord or the mortgage company, when are they going to want their money? They're going to want it at the beginning. So we're going to put a 1 right here, and I'll show you how to calculate this. The rate, now the rate's going to be different because remember, we're going to, and I didn't include rates of return here. So let me include, let's say our inflation is going to be 3%. Let's say our before retirement is going to be 10%. Oh, oops. 10%, and during retirement, okay, is going to be 7 or 6%. Okay, there we go. So what I'm going to do here on the rate, remember, I'm at 65 through 90. All right, so I'm going to be what? During retirement. So what I do over here is I put these in as decimals over here just to make things a little easier for me when I'm doing the formula. So remember, I'm going to be, during this time period of 25 years, I'm going to be earning my 6% during retirement. But in addition to that, inflation is going to be going up 3%. So I've showed you how to do this before, but let me show you how to do this again. So basically, to make it actually even easier, we could do 1.06 and 1.1. So we could do this as 1.06 divided by 1.01. Oops, I messed that up. It needs to be equals 1.6 divided by 1.1, and that is not giving me what I need. Hold on just a second here, I'll fix this. So we have 1.06, okay? So over here, to do the Fisher effect, we need to do equals, okay? Oh, and we also need 1.03, right, for inflation. So this will be inflation. This will be during retirement, and this will be before. And I just set them up there because you're going to have to start messing with all the parentheses, and I tend to mess that up really easily just because, anyway. So equals, open parentheses, I'm going to do, because it's during this, close parentheses, divided by, I guess you don't have to do the parentheses if you don't want to, but I always do this, and we need to do minus 1, and as you notice here, that gives us 0.029126, which we know that's right because after you do the Fisher effect is always going to be less than your rate minus inflation. That would be 3, but we know the actual answer is 0.029126, and goes on and on and on and on. So what do we do here? Well, we're going to solve for the present value. So how do you think we do that? It's really easy. Equals present value, open parentheses. Now look, it shows, okay, what's my rate? Well, my rate is going to be a combination of inflation and during retirement. So I choose that. So B6. Now watch, I'll hit comma. It goes to number of periods. So look, my number of periods is here. What's my payment going to be? I'm going to need a positive 80,000. So 80. So I'm going to choose this cell. So this will be B5 for my payment. What's my future value going to be? It's going to be 0. And what's it going to be? It's going to be at the beginning of the period. So you could either choose 1 at the beginning here, or you could choose it here. Close the parentheses, and there you go. What this says right here is that you need, in today's dollars, $1,447,684.71 in order to get $80,000 per year for 25 years at the beginning of each year. Okay, but that's in today's dollars. So this was step 1. Okay, step 2, and we're going to copy all this because it's easy. All right, what's our present value going to be? Okay, what we're going to do here is we're going to inflate this number. That's all we're doing here. So this is actually the easiest part. So what I'm going to do is it equals negative. To change that to a positive, what we're going to search for is the future value. The payment doesn't matter, okay, because we just want to find out what this amount today is going to be at retirement. Okay, so the rate is going to be what? It's just going to be 0.03. All right, our number, now think about this. What's our number going to be in this situation? Well, we're currently 30, so today we're 30, and we retire at 65. So I'm going to do 65 minus 30 and get 35. Beginning and end doesn't matter here. So what we're going to do here is, watch this. Earlier up here we used the present value function. Here we're just going to use the future value function. Going to equals future value, open my parentheses, my rate, my number of periods, my payment is 0, my present value is this number, my type is, we'll just do into the period, and close my parentheses, and voila. Oh, you know what? This needs to be my apologies. This needs to be a negative number because that's assuming we're going to invest that. That needs to be a negative number. So you invest, basically, it's like investing $1.4 million, and it gets us to a $4,073,585. So this is what we would need in tomorrow's dollars. Okay. So step 3, how much money do we need to start saving for retirement in order to meet this goal? Well, let's do this. Now, this is where some people make some mistakes, so I want you guys to pay attention here. Okay, so equals, what's our present value? Well, at this point, we assume we have nothing saved in retirement, so we'll leave that at 0. What's our future value? Well, we need to have what? We need to have $4,073,000. What's our payment? That's what we're going to solve for. What's our rate? Now remember, we've already inflated everything from age 30 to 65 right here. We took the lumps, the present value needs of $1.4 million, and we inflated that. So we don't need to inflate that again. So we're just going to use our our before retirement, because this is where we are accumulating. So we're taking a more aggressive portfolio. So 0.10. Okay, remember Excel, we got to use decimals, and then the number is going to be what? Well, it's going to be 65 minus 30, because it's the age, our retirement age minus our current age, puts us at 35, beginning and end. Well, that depends. We could just assume in this scenario that we're saving at the end of the year, so we put a 0 there. All right. So what am I going to solve for? What do you think? Yep, that's right. We're going to do PMT parentheses. What's my rate? Okay. Now what's my present value? Is 0. What's my future value? I need to have this amount of money, $4.073 million, when I retire. What's my, we're going to do end of the period, okay? And we are going to find out that, let's see here. Let's see here, our payment is messing up here somehow. Let me redo this again. I might have messed up on something. Our rate is 0.1. Our number of periods is 35. Our present value is 0. Our future value is this. End of the period. Okay, there we go. So I messed something up here. Well, what does this tell me right here? This tells me what? I need to save $15,000, okay, every year. For how many years? 35 years, and I need to get 10% per year in order to get $4,073,000. Now, what if I did have some money here? Let's say I was going to go ahead and say, hey, you know what? I'm going to drop in $300,000 in this calculation. I'm going to get an inheritance or something. Okay? Well, that makes it positive, so you don't. So let's do negative equals negative 100. Okay? Now I only need to save $13,000. What if I had negative $150,000? Okay, that makes it positive. So I don't need to have too much money, because see, this $150,000 over 35 years is that's making this payment now positive. Okay, so we could do equals negative 120, 1, 2, 3, and we need 27,000. Negative 135,000. See, and that puts us at only saving $1,032 per year, because we got such this large sum of money right here, and we're investing it for a long period of time. So remember, what this is saying right here, remember earlier when I did this? That's basically saying, no, this $300,000 investing at 10% per year over 35 years, that is enough to get us to our $4.073 million. So that's why that number is positive. So just remember, this is the basic way to set it up in Microsoft Excel. I just wanted to show you. So if I go back to 0, it says we need to save $15,000 per year. Okay. Now there's another cool thing you can do is, for example, what if at the future, what if at the beginning when you die you wanted to leave, I don't know, maybe a couple $100,000 to your alma mater, like UTD Finance? You could actually put in, make sure that I did that right. Yeah, future value. No, you're gonna yeah, $200,000 would be your future value. So that would change this, which changes that, which goes ahead and changes everything. Okay. So you could change, if you wanted to have some money left over to give to your family, you could, instead of putting 0 there, you could put the amount of money. But we'll leave it at 0. Okay? So hopefully this gives you an idea of how we will use Microsoft Excel to answer our problem regarding retirement. If you have any questions, please let me know. I'm here to help.